given an array A with even number of elements in it. You're asked to return a perfect shuffle of A. So let's take an example here. So let's say you're given this array here, and by perfect shuffle, what's meant here is you got to split this array into two halves, and you got to combine the two halves in such a way that they're perfectly interleaved. So this would mean that the output you're looking for is something like 1, 4, 2, 5, 3, 6. So perhaps this is a good point for you to pause and think through various options to get to this output. So let's talk about a few approaches here that come to mind. So for folks who are familiar with sorting, this might remind you of merge sort, wherein you have two halves and you are asked to merge the two halves such that they end up in an ascending order. Right, so here it's the only difference here is you don't have the comparison. You just actually blindly put the elements to the output order in the output array such that they're interleaved. So that's one approach. We'll just jot it down here. So you got merge sort. Yeah, just capture the time and the space complexity. So the time, as you may all know, it's big of n log n. The space is big of n because you need an additional space of size n to accommodate the output. The second approach we'll talk about is it's a in-place approach that involves a linear scan and swaps. So by virtue of it being in place, you basically need just a constant additional space, but the time complexity is going to be big of n square. So in this video we'll talk about the second approach. The first approach is fairly simple if you know how merge sort works. The second approach is a bit more interesting. So let's go with the example that we started out with. So I'm just going to write it out here again. So you have two halves. You got to interleave them. So which kind of means that you need to have some way to identify the next eligible element that you're going to pick from each of the two halves. So it's going to call these as I and j. These are two. Get to get these as two variables that point to the next positions that you want to consider when interleaving. So alright, so let's say you start out with I equals 0, so you write I equals 0 to the output, so you don't have to test this. Let's say what happens if you use, so you want to bring 4 as the next element in the array, so you have a 4 here, and so you're going to, what if you did a swap? Let's write that output. Okay, so that kind of in the right direction. So you have 1, 4, and you have as the first two elements in the array. Now you got to fix up 2 because 2 is not in the right position. It's supposed to be at I equals 2, but here it's at position I equals 3. So let's bring it to I equals 2 by doing another swap here. So you get 1, 4, 2, 3, 5, 6. Okay. So remember, your I is still at 0. J is pointing at 3. That's pointing at 3. Now let's. So you got the first 3 elements look good, right? Okay. So now let's increment I. Let's have I point to 2, and J would point to J plus 1, which is at 5. Let's do the same thing here. Now you're going to swap these two. Let's see. Yeah, you could swap these two together, and you would end up with 1, 4, 2, 5, 3, 6. Okay, and so that's giving you the first 4 elements look great, and that's in line with what you wanted. And so 3 is also in the right position that you wanted, and so that's sort of a terminating condition. So the idea here is that you would swap, you would do the swap, and then you want to, once you're done with the swap here, like for example in this case you swapped 4 and 2 positions 2, and what you want to do is you want to bubble 2 towards the left until it hits the right position, and the right position is indicated by doing a series of swaps until you get to the point where you hit you get to a point where the final position of the swap is, let me call it this way. Let's say you have, you call this as K, right? You want to swap until you hit, until K is greater than I plus 1. If K is less than I plus 1, then you would just stop, right? So that's the fundamental idea. I'm just going to write down the algorithm here. Might give you a better idea of how to code it up. So I'm just going to call it void perfect shuffle. So it takes int A. So what you could do is you could basically sort A if it's not sorted. But yeah, I think it's, if you can actually ignore this because you're given an assorted array. You can go with that assumption. Let's say I fix a variable called length. And say I set I as 0, j as line over 2. In this case, line 6. 6 over 2 is 3. And so I would iterate until j is less than len. So the first order of business is, as we did here, is you swap 2 and 4, which is 2 is at position I plus 1, and 4 is j, so you do a swap. And then you would, now you want to bubble 2 to the right position, which is you want to bubble it left. You want to go, you want to go up to a point where, let's I think it's maybe easier if I write it down. So let's say k is j, that is the current position of 2, right, after you did the swap. And then you want to bubble, you want to put 2 through a series of swaps until k is less than I plus 1. So while k is greater than I plus 1, you'd swap a of k with a of k minus 1. And then let's say you decrement k. Okay, so your swap is done. So, which means you got to this point. Then you would increment j, and then you'd also increment I. Then you would continue. So that's the pseudocode. Gives you a high level idea. I would say play around with this example and maybe pick another example. So for simplicity, let me just pick another example here. Let's go with 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you got, let's break that up into 2 halves. Okay, now let's say you start with I here, your J is here. Okay, so the first order of business is you swap I plus 1 and J. Right, so what you get is 1, 5, 3, 4, 2, 6, 7, 8. Okay, so now your 2 is supposed to be here. Now, the perfectly interleaved output is, I'm just going to put it down here. It's 1, 5, 2, 6, 3, 7, 4, 8. So your 2 is not at the right position. It's supposed to be it should be after 5, but the desired output, but it's way after 5. So you have to bubble it up. You got to swap 2 here, then you got to do another swap here, put it in the right position. So this is where what I call as K. I set K as on J, and then I do a series of swaps until, and this is I plus 1, until K gets less, until K ends up being lesser than I plus 1. So I do the swaps, and I end up with this as an intermediate array. So I got 152 fixed up. Now it's the same approach applies to the remaining array. So you fix up your I here, and you increment your J to 6, and so on and so forth. Alright, so that was